Today we're looking at 4C.1, and that is I can create a two-way frequency table to calculate simple and compound probabilities. So now we've looked at a frequency table, right, and now we're going to look at a two-way frequency table. And all that is it shows the frequencies of two different categories. So, for example, what flavor of ice cream would you pick? I want to not only know the flavor of ice cream, if they like chocolate, vanilla, or neither or another, I also want to know, right, what age they were. Okay, so here it shows the number of people that liked, the number of children that liked chocolate. Here's the number of teens that liked chocolate. Okay, a lot of times they'll have a total at the end. This one doesn't. It only has the totals down here, but usually it'll have totals on both, right? The age and the chocolate, or the question, whatever. Okay, so let's look at an example. Here we have attendance at soccer camp. So I just want the probability of a boy. Right? Well, I have to look for the, I don't care if they're in 6th grade, 7th, or 8th grade. I want to look at, sorry guys. I want to look at the total number of boys out of the total. 23 out of 50. Okay. Probability of 7th grade. Again, I don't care if they're a boy or a girl in 7th grade. I want the total 7th graders. So that's going to be 13 out of 50. And that can't reduce. 6th or 7th grade. Well, I can have 6th grade or 7th grade. So that's 15 6th graders plus 13 7th graders out of 50, which is 28, which reduces to 14 out of 25. Okay, so 6th or 7th grade, still looking at those. And this is because these are mutually exclusive. Right, so that's still coming into play. I can't be in both 6th and 7th grade. So looking at letter D, the probability of girl or 8th grade, well, I can be a girl and in 8th grade. So these are inclusive events. So I need to do the probability of being a girl, which is 27 out of 50, plus being in 8th grade, which is 22 out of 50, and then subtract your and. So it's 27 minus 22, and then I'm subtracting that 12. Plus 22 is 49, minus 12 is 37 out of 50. Alright, being a boy and in 7th grade. From a table, there is no way to tell if they're mutually exclusive or if they're independent or dependent. All we do for our and is we're not multiplying. I'm just looking for where the two of them meet. Being a boy and in 7th grade, there's 6 of them. And that's all you have to do. Okay, so your ors, you still have to add or subtract. For your and, you're just looking at that specific part of the table. So now, here, this is a little bit different. All right, the coach is splitting the group into 2 teams. What probably chooses a boy and then a girl. So here I was making one choice, and I wanted it to be both of these things. Here I'm doing one and then the other. Okay, this is dependent. Right, if I'm making teams, I'm not going to send the person back to be chosen again. Right, once you're on the team, you're on the team. So I'm going to choose a boy, and there's 23 out of 50 boys. I've chosen that boy. So both my number of boys and my total has changed. And so now, that's not right. Sorry, I'm choosing a girl next. So it should be 27. Where's my purple? 27 out of 49. I'm just going to... So we have 23 out of 50 times 27 out of 49. And we get 621 out of 2,450. That's not a lot, reduces there. Okay. And that is it. Okay, so for this, this type of and, I want a boy and a person in 7th grade, I'm still only choosing one person. This type of and, I'm doing this and then that. And so then we still have to do the multiplication. Okay, so kind of reading the question and being careful there. All right, looking at our next page, we can also create probability tables, or two-way frequency tables. In a class of 32 students, there were 8 girls who played basketball and 5 boys who did not. So first thing we need to think about is what our 2 categories are. Well, we have girls. We have boys. Then we have, I'll put a line here too. Oh, it's small. We have basketball. Right, they play basketball. Or not. Basketball. I abbreviate all the time. You are free to use whatever abbreviations for words you would like, especially on like tests and quizzes, as long as I still know what it means. So if you put BB and not BB, I would understand what that meant. Basketball and not basketball. I should also have a total down here. Okay. So in a class of 32 students, that's going to be our ultimate total. 8 girls played basketball. And 5 boys who did not. This table did not give us enough information. I will add a piece of information. 8 out of 12 girls played. I don't know why there's a missing piece there. 8 out of 12 girls played basketball. So 8 played basketball out of 12 total girls. That should be enough to give us the information. Okay. So now, we're filling in our pieces. The first thing we're going to do as girls, we did not play basketball. Well, if 8 played basketball and there's 12 total, right? 8 plus 4 equals, so that's kind of how we can think about it. All right, 8 plus 4 equals 12. The next one I'm going to fill in is how many people in total did not play basketball. Now I have 4 girls not playing basketball and 5 boys not playing basketball. All right, I'm going to add these. 4 plus 5 equals 9. Total people did not play basketball. I can find our total here. All right, 12 plus something equals 32, and that is 20. You can also do 32 minus 12 to get 20. Filling in here, blank plus 5 is 20. That's 15 plus 5 equals 20. And then 8 plus 15 equals 23. Then we can also check 23 plus 9 does equal 32. So everything should kind of work out in the end. So here's our lovely table. What is the probability of being a boy and playing basketball? Okay. There were 15 boys who played basketball out of 32 people. The probability of being a boy and playing basketball is 15 out of 32. The probability of being a girl or not playing basketball. Well, we're going to start with the probability of being a girl. All right, the probability of being a girl is 12 out of 32. Probability of not playing basketball, we have 9 out of 32. And then we have to do the probability of both being a girl and not playing basketball. Right? Being a girl and not playing a basketball is 4 out of 32. 12 plus 9 is 21, minus 4 is 17. Okay. Again, those are overlapping because I can find that there's something in that and probability. Those two things happen at the same time. Okay. All right. There are 150 children at summer camp, and 71 signed up for swimming. There were a total of 62 children that signed up for canoeing, and 28 of them also signed up for swimming. Okay. All I know here is people signed up for swimming and did not sign up for swimming, and people signed up for canoeing and did not sign up for canoeing. So those are going to be my two things. There are 150 children at summer camp. Fine, that's my total. 71 signed up for swimming. So I don't know nothing if they're under canoeing or not canoeing. I just know that there's 71 total for swimming. Total of 62 children that signed up for canoeing. Okay, so we got 62 total signed up for canoeing, and 28 of those also signed up for swimming. So 28 plus something equals 71. Again, you could also just do 71 minus 28, which is 43. Doing my quick mental math. Same thing here, 28 to 62. I believe that's 34. 62 to 150, that's 88. I believe, yes. 71 to 150, that's 79. 43 to 88, that's 45. And then 34 plus 45 is 79. So that all works out. And then our only question here is, what is the probability of swimming? 71. That was easy. I have another question for that. Guess that. All right, that is it. All right, I will see you guys on Monday.